Hello, and today's learning target is I can solve a system of equations through substitution, elimination, and solving word problems within systems. So we are going to look at continuing to solve equations, but today both equations will be in standard form. We will still look at using the substitution method, but then we'll also review the elimination method as well to solve. And really, it's just a preference on which method you would rather use. Sometimes the equations are set up so it's easier to use one method over the other, but really, whichever, you could use any method really to solve. So let's look at this first example. I'm going to use the substitution on this just to show an example with two equations in standard form and using the substitution method. So what I will do is I will write one equation in terms of a single variable. So y equals or x equals. So if I see a single variable, which I do in the first equation, I see y right here, I'm going to solve for that y, or get that y isolated by itself. So before I do that, I am going to make a minor change here. This should just be 3x minus 8y, not plus 8y. Okay, and now I'll go ahead and rewrite this first equation in terms of y, and again, that's because I want to use the substitution method. So I'll add 5x, y equals 5x minus 3. Now I can use the substitution method a lot easier. And I will go ahead and substitute the expression that y equals into that second equation. So I get 3x minus 8 times the quantity, 5x minus 3, equals 24. Distribute that, negative 8. 3x minus 40x plus 24 equals 24. 3x minus 40x is negative 37x. Subtract 24. And I get negative 37x equals 0. So it doesn't, even matter if I divide by negative 37. 0 divided by any number is 0. So now I'll take that value of 0 for x and substitute it back into either equation that looks easier to solve for y. And I'm going to go ahead and substitute it in the new equation that I rewrote earlier. So y equals 5 times 0 minus 3. 5 times 0 is 0. So y equals negative 3. So my final answer would be 0, negative 3, written as an ordered pair. All right, let's take a look here at one more example. So again, if I want to use a substitution method, I look for a single variable, which I see in the second equation of y. So I'll go ahead and rewrite that equation in terms of y. So adding 5x to the other side, and get y equals 5x plus 13. So now I'll take that expression and I'll substitute that in for where I see y in that first equation. And then I get negative 3x plus 3 times the quantity, 5x plus 13 equals 3. Distribute, negative 3x plus 15x plus 39 equals 3. Negative 3x plus 15x is 12x, plus 39 equals 3. Subtract 39 and get 12x equals negative 36. Divide by 12, so x equals negative 3. Now I can substitute that back into an equation, either one I choose, whichever looks easier. And I'll go ahead and plug that into the new equation that I rewrote from earlier. So y equals 5 times negative 3 plus 13. Negative 15 plus 13 is 2. So my final answer, written as an ordered pair, is negative 3 comma 2. And again, I could check my answers. This would be very good to do on an assessment, right? Plug this ordered pair back into both equations and make sure that it holds true and that it works for both. So now we'll continue to look at solving a system of equations, but now we are going to use the elimination method, which means we want to eliminate a variable so that we only have to work with the other variable, right? One variable to work with is easier than two. So similar to the substitution method when we were getting rid of a variable, but now we are actually going to eliminate it. And if its equations are already written in standard form, that makes it even that much easier to use the elimination method. So let's take a look at a few examples, and we may not do all of these examples, but we'll take a look here. So with using the elimination, I want to see variables that have either the same coefficient in front of them, or I want to see opposite coefficients. So here I see, a negative 4y and a positive 4y. So for me, I'm looking at that and saying, okay, I could get that to a 0y by either adding or subtracting. The negative 4x and the 6x, you would need to multiply them so that they turn into the same, so that they have the same coefficient with the x variable, but that would require a little bit more work, and this would be easier if we eliminate the y's. So if I have negative 4y and a positive 4y, to eliminate that, those y's, I'd want to add the two equations together. So I add across. Here I'll look at the negative 4x and 6x, and negative 4 plus 6 is 2x, and negative 4y plus 4y goes to 0y, so that's where the elimination comes into play, and 4 plus negative 8 is negative 4. And now I solve for x, and x equals negative 2. Now I've got my x variable answer, but now I have to figure out what y is, so now I'm going to substitute negative 2 back in to either equation that looks easier to plug this negative 2 in for x, and I'll do that. I'll plug it into the second one. So 6 times negative 2 plus 4y equals negative 8. And like I said before, it really doesn't matter which equation you plug it into. You should get the same answer if you complete that correctly. So I'll bring that right up here so it's easier to see. If I add 12, 4y equals, this is negative 8. So negative 8 plus 12 is 4, so y equals 1. So my final answer is negative 2, 1. So now let's go ahead and look at the example right below. So 20x plus 7y equals negative 29, and negative 10x minus 5y equals 25. So as you see here, there are no x's or y's that have the same coefficient that actually will line up and be able to be eliminated with either adding or subtracting. So now here's where multiplication comes into play, and I want to turn one of the coefficients into the other of the same variable. So if I'm looking at this, I could turn the negative 10 into a 20, no problem. The 5 and the 7, I would actually have to multiply both equations so that the 5 and 7 have or turn into the same coefficient. So I'm going to go ahead and multiply the second equation by 2. So my first equation stays the same, so I still have 20x plus 7y equals negative 29, and now this turns into negative 20x minus 10y equals 50. And now I'm going to go ahead and add the two together so I can eliminate the x's, so 20 plus negative 20 goes away. 7 plus negative 10 is negative 3y, and negative 29 plus 50 is 21. Divide by negative 3, so y equals negative 7. Now if I plug that back into either equation, I'll go ahead and plug that into the second one. Negative 10 times negative 7 minus 5y equals 25. Get 70, oops, I plugged that in for the wrong one. Wrong variable. Here we go. Negative 10x minus 5 times negative 7. So negative 10x plus 35 equals 25. And we'll go ahead and subtract 35. Divide by negative 10. X equals 1. So writing my final answer as an ordered pair would be 1, comma, negative 7. Okay, and so with this last example, not necessarily going to go through it, but to be able to use elimination method, I would just multiply this top equation by 6, so that way the y's line up. Occasionally you may see some problems, and we will practice this in class, where you would need to multiply both equations so that the coefficients are able to be eliminated. Didn't necessarily go through an example here, but it's the same concept. We want to turn the coefficients into the same so that we could eliminate those variables. So feel free to give this example a try if you would like to. And if you decide to go through it, the answer will be -3, -2. We will also talk about some examples of, no solution or infinitely many in class as well. We've already spoken a little bit about what those types of systems of equations would look like, but again, just knowing that there are always 3 possible solutions of, one solution, or 3 possible scenarios: one solution, no solution, or infinitely many. And again, we'll be able to see some more of those examples in class. Okay, let's go over just a few word problems, how to set them up, and then of solving. So this first one says -3 times one number plus 5 times another number is -11. So I'm gonna, before I even read the second sentence, I'm gonna write what that sentence is with numbers and symbols. So -3 times one number, which we'll call x, plus 5 times another number, which we'll call y, means equals -11. Now the second equation, 3 times the first number, 3x, plus 7 times the other number is -1. Find the unknown numbers. I'm going to use the elimination method because I see the x's are actually already lined up with the -3x and +3x. So I'll go ahead and add these two together. So 5y plus 7y is 12y equals -12. So y equals -1. Now I can go ahead and plug that back in to solve for x. So I'm going to plug that back into, let's do the first equation, or the second. 3x plus 7 times -1 equals -1. 3x minus 7 equals -1. 3x equals 6. Therefore, x equals 2. So my final answer would be 2, -1. So again, it just setting up from a word problem and then being able to solve. So now we'll take a step up here with this word problem. This will be the last example on our notes. Got to finish the notes strong. So Cheryl and Jackie work at an ice cream shop. Cheryl earns $8.50 per hour and Jackie earns $7.50 per hour. During a typical week, Cheryl and Jackie earn $299.50 together. One week, Jackie doubles her work hours and the girls earn $412. How many hours does each girl work during a typical week? There's a lot of information here, so let's break this down and let's write our first equation out. So we'll call C Cheryl's hours and J Jackie's hours. And so with this first sentence, I'm going to reread it, or the sentence I want to look at to translate. Cheryl earns $8.50 per hour. So I'm going to say 8.50, 8.5 times Cheryl, because Cheryl earns $8.50. Jackie earns $7.50 an hour. So plus 7.5J. And together they earn $299.50. Okay, now 1 week Jackie doubles her work hours, so Cheryl stays the same. So 7.5 times 2 is 15, and then they earned $412. So the hard part is over. Setting up the problem is done. Now let's solve, and I actually already see variables that are lined up with the same coefficient, so I'm going to use the elimination method and subtract and get rid of the variable C. So 7.5J minus 15J is negative 7.5J equals, subtract 412 from 299.50 is negative 112.50 divided by negative 7.5. This is good, our negatives will cancel out because you can only have positive amount of money here that they're making. So when I solve here, J equals 15. So now if I want to solve for C, I'm going to go ahead and plug that back in. We'll go ahead and plug that into the first equation. So 8.5 times C plus 7.5 times 15 equals 299.50. Let's see here. 8.5C plus 7.5 times 15 is 112.50. Let's subtract 112.50. 8.5C equals, that's 187. And then we'll divide by 8.5. 187 divided by 8.5 is 22. So what this means for our answers is that Jackie works 15 hours in a typical work week, and Cheryl works about 22 hours in a typical work week. Thanks for listening. Have a great day. Bye-bye.